All right, hey folks, how's it going here? Mr. Fortin, going over the, I'm on Zoom and it's telling me I'm muted. Anyways, whatever. I'm going through the homework examples from problem section 3.8, which is called inductive reasoning. Now we're reviewing what inductive reasoning is versus deductive reasoning. So you watched the lesson video yesterday. Hopefully you get it, right? Inductively is learning through observations, and sometimes we can't always trust our observations. So if we're reasoning inductively means we're coming to it to a conclusion that we've seen through observations. Oftentimes our observations are pretty accurate, right? We can be pretty good at observing things and deduce or not inferring things that are actually true, but you can't always learn through observation. So the thing that we're doing mostly in this class this year so far is reasoning deductively, actually proving things that can't be argued with because we have facts, rules, and definitions by which to make our arguments here, okay? Prove a theorem by using given premises and using facts, right? Other theorems, rules, postulates, right? And definitions, which are just definitions, to build a chain of reasoning to prove something deductively. So anyways, this section is a little bit different. We're gonna jump into it right now with number 6. It says, guess the next two numbers of each sequence. So very simply, if it says guess here, right? If it says guess here, we're gonna have to, in this problem here, reason inductively, okay? So inductive conclusions are oftentimes guessing based on particular evidence that you have, that you've observed. And here, we can't base our next guess, right? We can't base on what the numbers are going to be here because we don't have a rule for this one, right? We don't have a rule or a definition or a fact or something by which has been stated, you got to follow this rule in order to get the next two numbers to do this. So we need to do this by our best guess, by our best pattern solving and finding this one here, okay? So what this is called is something called a sequence, right? A sequence is something, I'm hoping if you took Algebra 1 last year, you've already studied sequences a bit, but sequence is our discrete set of numbers that are comma separated, right? Our first number of the sequence, the first term, these are called terms here. This is the term number 1 is 10, term 2 is 12, term 3 is 16, right? And the question is, what's the next in this sequence of numbers? What's going to come next here, okay? So through our observations, you have to observe and make a conclusion here. So one observation you have, one inductive conclusion you can make just about this sequence in general, if you're observing something, you're inferring something inductively, is that the numbers are all even. So our next numbers here are going to be even, right? Going to be even. And then they're even, what else can we say? Okay, well, we're increasing. The pattern is definitely increasing. We're going up by how many? We go up by +2 here, +4 here, +6 here, +8 here. So what's the pattern? If I'm going up by +6 here, if I'm going up by +8, what can we infer the pattern is? Well, we're going up by even numbers, and the change is even too, okay? We go up by the smallest even number, which is +2, then go to +4 and +6, +8. So what's the next one going to be? +10, right? +10. So here we're increasing by +2 additional each time. Okay? And we started at 10. Okay? So we went from 10, we +2, which is 12. +4, which gets us to 16. So anyways, this is something called a quadratic sequence. Yes, quadratic sequence. Maybe you studied that last year, and right, you'll make connections in the future if not. So we can infer that this is going to be a quadratic sequence. And infer, right? We don't know for sure, right? There might be some other rule that this thing is following that we don't know about that's a little more sophisticated. But the idea is that if this is going up by +2s every single time, like 2 higher each time, and then this would be +10 to here. So 40, and then we go by +12 here. So 40 + 12 is 52. So hopefully you get that as the answer. Hopefully that makes sense, right? And hopefully this is a return to maybe some sane mathematics, some sort of like, okay, I can spot a pattern, I can break it down, boom, I got it, I'm good to go, move to the next thing. Okay, so do your best there. We'll review that in the Jamboard tomorrow. Here's another one here. It says, there are 3 sisters. Okay, so we got sister A. We got nuns here, right? Those are sisters, right? Sister A, and then sister B, and then sister C. Okay, sister B and sister C. 2 of them are athletes and 2 of them like tacos. Can you be sure that both of the athletes like tacos? Okay, so maybe we'll address that first. That first question here is this. Can you be sure that both of the athletes like tacos? Well, let's see here. Sister A, so the two of them, all we know is our given premises that two of them are athletes. So let's say that A, for instance, is a hypothetical. Let's see if we can maybe observe this here, the situation where hey, we're going to conclude this through observation. Let's check it out here. This is an athlete, okay? Maybe make sister C an athlete. The question is, can we be sure that based on these inputs here, right? One, two of them are athletes, and then two of them like tacos. Those are our two given premises of this particular situation. Can we be sure that these are the ones that are both athletes and tacos? Can we be sure about that? Two of them are athletes and two of them tacos. Well, those given premises could have been split this way, right? It's possible that sister A would like tacos, but it's possible sister C is an athlete who doesn't like tacos, and sister B is the one who likes tacos here. Okay, so here we have the given premises. Given premises one is that we have two sisters here that are athletes. Given premise two is that we have two sisters that like tacos. So my given premises here are true in this situation, but the conclusion that both the athletes that like tacos is false. Okay, so I would say no, we cannot conclude this, because we could have this situation as our if then, right? If two sisters like tacos and two sisters like athletes, then we can't conclude that both the athletes like tacos, okay? Odds are, right, if you're into sports, you're working out hard, you want to eat a lot, tacos, they deliver some good nutrition, but no, we can't be sure about that. Maybe like burritos instead. Who knows? So we cannot conclude that. And then it says here, second part of the problem, do you reason deductively or inductively to conclude the following? They should have kind of a colon here. They have a colon here. It says at least one of the athletic sisters like tacos. Okay, at least. I think that's kind of a good logical reason there. And I'm actually debating this. Is it actually inductive or deductive? I might have to check the answer key on this one here. So the idea of this is, well, yeah, like two of them like tacos, so it could have either been here or it could have been here, right? If so two of them like it. So one person, let's say sister A likes it. The other combination is either sister B or sister C is going to like it, okay? If sister C definitely liked tacos, then either sister A or sister B would like tacos, okay? So remember, two of these got to be athletes, one of them not an athlete. If two of them like tacos, that sort of is going to make it mandatory that at least one of them has to be an athlete, right? Am I wrong about that? It's a true conclusion, but is it deductive? I don't know. I'm going to put not sure. I'm going to put not sure to begin with here. We're not basing it off of a definition. We're not basing it off of a fact, of a theorem. We're not basing it off of a rule to follow. So I don't know. I'm not sure, to be honest. I'll be completely honest about that here. Do you reason inductively and deductively include that? Yeah, I mean, deductively, you only you starting with only have three sisters. That's what's given to you. Two like tacos, one doesn't. So I don't know. I have to look up that one here because it's not really based on observation. It's based on viewing all cases. I don't know. I have to look that up. Anyways, so I figured I'd put that one on there because some of these ones you have to really think though and think about. Maybe they have some more in the answer key that can kind of justify that one for me. But anyways, we'll talk about that one in the gym board, I guess. Number 20 says draw several quadrilaterals whose opposite sides are parallel. So this must mean two pairs, right? Have two pairs of opposite sides. Okay, that's the only way we can draw a quadrilateral that is a quadrilateral, right? That actually you can draw the figure where we have sides that are parallel. This is if you have two pairs of that. So here, that side and maybe this side, let's make them parallel. How do we have to do it? Well, I have to have those parallel, and I'd have to have these parallel. So those look parallel here. Okay, so I'll draw that one, and I'll draw this one. Okay, there's one. I'll draw like three of them for you, I guess. Sure, it could be a rectangle. Okay, maybe another one, maybe like a diamond-ish type thing. If I get those parallel to each other, and then these parallel, maybe. That's a rectangle. I want to stay away from rectangles here. Maybe I'll extend this there. Okay, and then I'd have to do this right there. Okay, so here we got a quadrilateral. We can ignore this, ignore that over there. We got three quadrilaterals whose opposite sides here, opposite side here, parallel. These opposite sides, parallel. Okay, these opposite sides, parallel. These opposite sides, parallel. Okay, so what is the question asking us here? With a ruler and a protractor, measure the opposite sides and the opposite angles of each figure. On the basis of the diagrams and measurements, what do you guess is true for all such quadrilaterals? So I don't have a ruler, but I have grid paper here. So let's check this one out. I'm going 1, 2, 3, 4, 5, 6 or so in length for this side. 1, 2, 3, 4, 5, 6 or so in length that side. Okay, so interesting. Opposite sides are congruent. And then we're going up 1, 2, 3, going up 1, 2, 3, and over a couple here. So yeah, it looks like the opposite sides are congruent here. So my guess is this is what they're trying to show us here, is that the opposite sides of a quadrilateral, where we have opposite sides parallel, if we know the opposite sides of both pairs of opposite sides of a quadrilateral or parallel, then the opposite sides will also be congruent. So it appears so. Maybe this is a postulate. Maybe this is a theorem we could prove, but the key is we haven't proven it yet, okay? So I agree here, right? This side, that side look the same. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then I went a little too far here, right? This should have been more like that. So it looks like that side congruent to that side. Yeah, I agree. That side looks congruent to that side, right? We're going up 3, up 3. This is why grid paper is really good for geometry. Usually they're required again. Here we're going over 1, 2, 3, 4.5. 1, 2, 3, 4.5, right? So these look the same. These look the same. Okay, so it appears to us from the naked eye that opposite sides, okay, opposite sides, right, of a quadrilateral, so we haven't defined a parallelogram that, of a quadrilateral with opposite sides parallel, we're guessing that they are congruent to one another, right? Those opposite sides are congruent. Okay, what about the angles? What about the angles? Do you guys do that one yet? Do you do angles yet? Well, let's check it out here. This is an obtuse angle. This is an obtuse angle. Yeah, that looks about the same. These look about the same here. Okay, so it looks like our angles are also the same here. So I'll take this off. Question mark. Do we know for sure? Well, it looks so, right? It looks so, but have we proven it yet? So is this a theorem? Is this a postulate? Okay, so through observation, you can probably come up with conclusions that are probably true in geometry. But do we know that they're true for sure? Because remember, the naked eye can deceive. We don't know yet. We're going to have to prove these, and we'll prove these in chapter 4. Here, these are all right angles. I drew this as a rectangle. So if it was given to us, we had a rectangle, then we'd say yes. But here, right, this is just, I just tried to draw this as a quadrilateral as opposite sides are parallel, and it does look like all of these angles are congruent. But most important, the opposite angles are congruent here. I'll put question marks down here, so we haven't actually proven it yet. Here, let's check it out here. Well, this is acute, that's obtuse, that's obtuse. I drew it. It was very ugly how I drew this, but it looks like those angles are also congruent to one another, right? Also looks like it, but we're not sure. Okay, opposite sides of a quadrilateral with opposite sides parallel are congruent, and then opposite angles of a quad whose opposite sides are parallel are congruent also. Okay, congruent also. Can we use these facts in a proof? No, we can't yet because we haven't proven it yet. So just to emphasize this here, the reason why you have this question is because on this one here, number 20, okay, we reasoned inductively, right? Inductively. So if you did this exercise with me, you're still having trouble figuring out what the inductive reasoning is and deductive reasoning is, it's through what's visual, right? Visual. So I can visually tell this, and then I think this is true because I keep seeing it. So I'm coming up with a conclusion based on inductive reasoning. Okay, we haven't proven this fact yet, because these are provable facts. We'll prove these ones in chapter 4, and we'll actually prove it based on the laws of geometry that these statements need to be true, rather than just we think they're true through inductive reasoning. They'll be true through deductive reasoning. Thank you for watching. Best of luck on your homework. I think this one should flow. You guys should do A-okay with this. Email me if you have any questions. Have a great rest of your day, and then we're done, right? We're done with all new chapter 3 stuff. Just got to review chapter 3, and then you'll take your test, and we'll be good to go this semester. Have a good day, guys. Bye.